our kitchen. I'm Boyana.
I'm Ryan.
I'm Jensen.
So today we are going to teach you how to cook a universe from the Big Bang
To the formation of the solar system
and to the formation of Earth.
Hi guys, I'm the founder of the Big Bang food industry. Today I want to show you how to make the most popular snack, the universe. The cooking process is super quick with enormous energy and heat released. Please be careful when you're cooking it. First of all, we'll start with this magical balloon, which we call the Big Bang Singularity. You can easily find one in our online store. I can only tell you that it contains enormous amount of pure energy. The balloon will go through quick expansion. As you can see that the points on the balloon are moving further away from each other during the process. Bang, you have a universe. So in order to win this contest today, I would like to explain to you what happens inside the balloon. In the first 10 to the negative power of 43 seconds, which we call it the Planck epoch, temperature and pressure are so high that everything inside is in one form, energy. Then in the next 10 to the negative power of 35 seconds, which we call the inflationary epoch, inflation happens and the size of the tiny ball expands to about 10 to the power of 7 of the original size. The temperature is still super high inside at this time, but the heat is evenly spread inside the bag and the density decreases so that we can condense out matter. After the inflation, the bag is about 1 billion kilometers big, with many complex reactions happens inside. At the end of the first second, the temperature is much lower comparing to the beginning. Now we have produced a huge amount of quarks, leptons, and most importantly, protons and neutrons. In the next 100 seconds, the bag keeps cooling down, and we enter nucleosynthesis era, in which neutrons and protons could link up to make the first atomic nuclei. Here's an explanation of what's happening in the nucleosynthesis. In short, 6 hydrogen atoms collide and go through nuclear reaction to make a helium atom. Hydrogen is composed of 1 proton, and helium is composed of 2 protons and 2 neutrons. In the first step, 2 protons bond together, and by releasing an electron with positive charge, one of the protons becomes neutron. This process happens twice so that we now have 2 heavy hydrogen, each has 1 proton and 1 neutron. In the second step, 1 neutron is added to it so that now each of them has 2 protons and 1 neutron. In the last step, these 2 atoms collide together and kick out 2 protons, so that we now have a perfect helium with 2 protons and 2 neutrons. This nuclear reaction happens again and again inside the balloon, and if we leave the balloon somewhere for 1 day, the inside space of it will be composed by 75% of hydrogen and 25% of helium. If you are patient enough to wait for 300 million years, the weak fluctuation in the density of the hydrogen and helium gas causes gravitational attraction towards the dense region and keeps attracting more and more matter. Matters keep accumulating and attracting each other's, and at the end, the first stars was born.
Now I'm going to show you how to create the solar system. After the Big Bang, you'll have to wait around 9 billion years before you can start preparing the solar system. You may be thinking about setting your phone alarm, but since your phone's battery probably won't last that long, I recommend using uranium-238 as a timer instead. Geologists use radiometric dating as a way to measure how old the Earth is by seeing how much of what isotopes of radioactive material are present. Similarly, we'll be using the decay of uranium as a way to measure time. I'm going to be starting with 12 atoms of uranium for demonstration purposes, but for more accurate results, I recommend using more. I would advise against eating too much uranium considering that 1 gram has around 20 billion calories. I'm now going to place the uranium in a spot that won't be disturbed for the next 9 billion years.
1 eternity later.
6 of the 12 uranium atoms have now decayed into lead-206, And since uranium's half-life is 4.5 billion years, we know that we're halfway done through the 9 billion year wait time.
1 eternity later.
Now that 3 of the 6 atoms that hadn't fully decayed yet have now decayed, we know that we're 9 billion years after the Big Bang and we're ready to form our solar system. During those billions of years of waiting, I made sure I had a star at least 15 times the size of the sun and a giant dust cloud. In the star, hydrogen fusion will be taking place. This is just like what we saw during the Big Bang. 2 protons will collide with each other, and then one of these protons will lose its positive charge and become a neutron. After this, another proton will combine with these to form a helium atom. And another helium atom of the same isotope will collide with that. 2 extra protons will be thrown away from this, and that will form an alpha particle. The energy produced from the removal of those 2 protons is where most of the heat and pressure from fusion come from. Without this, the star would collapse in on itself due to gravity. And this is what happens once all the hydrogen burns up. As the star collapses in on itself, the star will become extremely hot and dense, and the helium will start fusing with itself, causing the star to once again expand. Elements including carbon and oxygen, and every element on the periodic table leading up to iron will be produced from this fusion as the star continues to expand. But the star won't be able to fuse iron, and this is going to cause the star to collapse in on itself yet again due to gravity. What happens next might be dramatic, so I'm going to be putting on safety goggles just in case something goes wrong. The star is so massive that this collapse will cause a huge shockwave as the star goes supernova. This is going to happen in 3, 2, 1... Thank God I was wearing my safety goggles.
A plastic water bottle and a paper towel roll.
Look at all the new elements beyond iron that have been produced. The shockwave was strong enough to cause our dust cloud to collapse. But keep in mind that much of the dust from the cloud won't make it into our solar system. The dust that will make it into our solar system is going to be part of our cloud core, which is in this pot. The vast majority of this cloud core is clumping in the middle and is forming the sun.
I am in Spain without the A.
You're in spin?
Wait!
The cloud will start to spin, which will cause it to flatten out onto a plane due to centripetal force.
Thank you, Brian, for taking us through the process of the creation of our solar system. Now let's shift our focus and look at how to make our planet and the livable Earth. As a chef, we're constantly exploring and improving our cooking skills, just like how scientists are constantly modifying theories with new evidence. How to cook a planet is still a controversial question, but we do have 2 leading theories on planetary formation. According to the core accretion theory, planets were formed by heavy elements colliding and binding together due to gravitational force.
Gravity is working.
Lighter elements were blown away due to solar winds, and the only heavy elements were left to accumulate. This theory well explains the formation of terrestrial planets like Earth. On the other hand, this instability theory suggests that gas giants were formed due to the gravitational instability of the protoplanetary disk. To make our planet, we have to first sparkle some dust into the pot. As you prepare your ingredients, be careful of the nutrition facts. These dust particles have to have rich carbon and iron elements. That is essential to the taste. As you stir and stir the ingredients, you will see dust clumps up. Some will break apart as they crash into each other, but many of these dust grains will grow under the condition of condensation and accretion. These clusters of dust grains are called planetesimals in culinary terms. Planetesimals grow big enough to attract more dust through gravitational force rather than by chance. An important tip from world-class chefs is that you have to stir in the same circular direction, around the sun. Stirring in the same direction helps your ingredients to grow bigger and prevents much of the crashing. If you mix all your ingredients randomly, it is destructive and you will end up with a mess. Since the pot is heated unevenly, different planets are formed in different areas of the pot. Near the outer layers of the pot where the temperature is low, ice particles and gas can catch onto the dust and spin with them. At this point, gas giants such as Jupiter, Saturn, Uranus, and Neptune are formed. And now let's look at the hotter regions near the center of the pot. The energy that the sun sends out, called stellar winds, blew off near gases. The rocky planets are formed with mostly rocks and metal, and they are called Mercury, Venus, Earth, and Mars. Now let's shift our focus onto our Earth. As the timer hits 3.6 million years, Earth is a giant ball of magma. Due to high pressure, radioactive decay of isotopes, and collision with rocky debris, our Earth is extremely hot. Keep your bare hands away from our baby Earth. As you can see from our demonstration, Earth's core formed first, with heavy elements colliding and bonding together. As cooling takes place over hundreds of millions of years, you'll be able to see the layering in Earth, with a thin crust of light rock near the surface, a thick mantle of rocks, and a mostly iron core in the center. And here is our Earth. As for the development of Earth's continents, atmosphere, moon, and how Earth becomes livable for organisms, please like our video and subscribe to our channel for the next video.
I know you're gonna say something different. I like the marshmallows the best. That looks most appetizing to me. I know you don't like chocolate.
See, I don't like chocolate, so those both look horrible to me. So probably this one, because gummies are fantastic.
This is the Big Bang, right? Alright, well there's like the popcorn taste, so it wasn't that good, but it was better than this other stuff, I guess. Okay. For the food, I guess.
Okay, so this one is definitely sweet, but if you eat it along with the popcorn on the sides, it adds some kind of that salty flavor to it, which means that there is this kind of layer to this dish, and that's what I really like. And about this one, the uranium, it's got that kind of grape flavor, but this is just a kind of my personal thing. I don't like berries and grapes that much, so that one can pass. And this one, I love chocolate and marshmallow. It's sweet, it's chocolatey, and I think this is on the same rank as the Big Bang. Yeah. And about this one, it's really interesting how the creator decides to add like so many different colors to it. And I feel like in that way, this dish, this dessert, has an aesthetic appeal to the taster. And in terms of the taste, it's fine. It's got a kind of cinnamon taste to it. So if you are going to let me to rank for all of these for desserts, I will rank this is the top dessert. This will be the second, third, and fourth. Yeah.
Okay, thank you.
Hi guys, thank you guys for giving me this prize, and we are welcoming you to go on our online store and buy the universe by yourself and cook it in a balloon. Thank you so much.
Ooh! It looks like COVID.